In this video, I'm going to teach you what mass number is and how to apply it. So mass number, first of all, is not on the periodic table. Okay, let me repeat that. Mass number is not on the periodic table. Okay, a lot of students mess this up. So each element has two numbers on the periodic table. There's the atomic number, which is an integer. That's the number of protons. And then there's this other number that's typically not an integer. It's typically a decimal. This periodic table is calling it the atomic weight. More accurately, the atomic mass, or I like to use the term average atomic mass. Now that's very closely, that other number, the atomic mass or atomic weight or average atomic mass, is closely related to the mass number, but it's not the same thing. Mass number is not on the periodic table. So mass number is the number of protons plus neutrons in an atom. Okay, so if you remember when I sort of covered the discovery of all the subatomic particles, protons and neutrons both had a considerable mass, but electrons had a very, very small mass. And I said we're going to essentially ignore it for most purposes in chemistry. Okay, so electrons have a negligible mass, protons and neutrons do not have a negligible mass. They have about the same mass as one another. So each proton and each neutron contributes to the mass number. And this must be an integer because you can't have a fraction of a proton or a neutron. So the sum of the protons plus the neutrons must be an integer. So the mass number will always be an integer, whereas this number, whatever you want to call that, the atomic mass, average atomic mass, atomic weight, is typically not a whole number, okay? It's more of an average, which is why I like to call it average atomic mass, but I'll save that for a future video, okay? So for right now, we're focusing on mass number of protons plus neutrons in an atom, okay? Not on the periodic table, will always be an integer. So since it's not on the periodic table, that means that the mass number does not define what element it is. If I have an atom that has a mass number of 10, I can't determine what element it is. If I have an element with an atomic number of 10, well, that has to be neon, because atomic number, each element has its own atomic number. Each element does not have a defined mass number, so mass number does not tell you what element it is. Similarly, knowing what element it is does not tell you what its mass number is. Okay. Now, a common way of notating sort of atoms or nuclei is this atomic symbol notation, where we write the element symbol. This X is kind of a placeholder for the element symbol. By symbol, I mean these big 1 or 2 letter abbreviations for each element. We write that kind of here. And then in the bottom left, we write the atomic number. And then in the top left, we write the mass number. And then these are some abbreviations you'll see oftentimes. I have no idea why A is used for mass number and Z is used for atomic number, but it is. I did not make it up, okay? So, for example, if we have, let's do that. If we have this, how we read this is this means that our element symbol is Na, which is right here. That is sodium. So most periodic tables will write both the symbol and the full name. You probably cannot see the full name. It is written on this periodic table, but it's probably too small for you to see. But go ahead, pull out a periodic table of your own to follow along. Na, and you'll want to memorize the symbols for the common elements as well, which sodium is certainly one of the most common elements in chemistry. So Na is sodium. And then the atomic number is 11. That's what this tells us, which of course that is consistent with the periodic table. So that's good. If this was Na, this has to be 11. This can't be anything other than 11 because that's the atomic number of sodium. And then this is telling us that 23, that's the mass number of this sodium atom. Okay, now this would not have to be 23 because again, mass number, it's not on the periodic table. And so it doesn't link to the same element 100% of the time. So sodium does not have to have a mass number of 23. A mass number of 23 does not have to be sodium, but in this case it is. So we could do some things with this. One thing we could ask is how many protons and how many neutrons are in this atom? Well, the atomic number is the number of protons. Okay, so the atomic number, or Z, is the number of protons. I covered that in my last video. So if the atomic number is 11, this has 11 protons. And then it's telling us the mass number is 23. Well, that's the number of protons plus neutrons. Okay? Well, if we have 23 protons plus, I'm just going to write P plus N. We have 23 P plus N. And so we break that down into protons and neutrons. We know 11 of them are protons, so the remaining 23 minus 11, which is 12, must be the number of neutrons. So if I see this notation, then I know that it has 11 protons and 12 neutrons. Now there's two other sort of alternate ways to write this notation. One is we don't really have to write the atomic number. So you could see this written just like that, without anything there, because the 11, as I kind of mentioned, is kind of redundant, because if we know it's sodium and we have a periodic table, which you'll always have access to a periodic table, any test you take or anything like that, except maybe like when you have to memorize the element symbols at the beginning of the year, then, you know, probably not for that if you have to do that for your class, but after that, unless your teacher is really mean, you'll always have access to a periodic table. So if we know it's sodium and we look at the periodic table, we know the atomic number is 11. So we don't really have to include that information. We can, there's nothing wrong with writing 11 there, but it's not really necessary. So we could just write it like that. And then lastly, sometimes you'll see this written with the full name spelled out, so sodium, and then a dash, and then the mass number. So like that. So these three things all mean the same thing. And in fact, these two, if you were trying to like read it, like if this was if this was written and you were trying to like read it orally to somebody else, you would read this as sodium 23. So this last way of writing it is also kind of how it's read or spoken, even if it's written one of these other ways. So those three things all mean the same thing. So let's look at one more example. Let's say I have an atom that has (25) protons and 28 neutrons. 25 protons and 28 neutrons, and I want to write the atomic symbol for that atom or that nucleus. So the first thing I'm going to do is, well, I suppose the very first thing you could do is you could write the atomic number in the bottom left corner. Well, that's just going to be the number of protons. So that's going to be 25. And then the next thing you could do, well, there's two things you could do next. I guess let's do the mass number next. The mass number is the protons plus the neutrons. So I'm going to add these up. 25 plus 28, that's 53. So I'm going to write that above the atomic number. Okay. And keep in mind, on the periodic table, it's a little confusing. Like on the squares on the periodic table, the atomic number is not necessarily written in the bottom left corner. Like on this periodic table, the atomic number is actually written in the top left corner, but this is not trying to convey the exact same thing as this notation. They're not quite the same notation. So don't get that confused, okay? This is a specific type of notation, okay? And in this notation, we write the atomic number in the bottom left and then the mass number in the top left. But on the normal periodic table, again, the mass number will not be on there, and then the atomic number is usually written actually in the top left, but you know, it kind of can vary from one periodic table to another. And then I'm going to determine what element this is. So how do I determine what element it is? Well, not based on the mass number, based on the atomic number. So I look for what element has an atomic number of 25, and that's right here. That's manganese, which has the chemical symbol Mn. So that would be my answer for the atom or nucleus that has 25 protons and 28 neutrons. Of course, I could also write that two other ways, like we just talked about. I could write it like that, with just omitting the atomic number, and then I could write this third way where I write the full name, manganese, and then dash the mass number, 53.